So now come to question number 21. Exercise 1, phase 2, ellipse. Prove that the circle on any focal distance as diameter from the auxiliary circle. So what is the meaning of that? This is any ellipse is there. There is a point P and this is a point S. Somewhere I will take P and S. This is S and this is suppose P. Then focal distance, this is diameter. If I draw a circle here, so this circle will touch the auxiliary circle. What is the auxiliary circle? X square plus Y square A square. So now a circle with PS as diameter. PS as diameter. So this circle, see this, will touch the auxiliary circle. So for touching internally, because definitely auxiliary circle will be like this. So for internal touching, if this is C1, auxiliary circle is this C2. So C1, C2 must be equal to R1 minus R. That must be the concept. And A will be larger. Here R1 is A. So I have to find the center. So for that, P, focal distance PS, we know focal distance. Focal distance for this will be A minus EX1. With this, it will be A plus EX1. So this is the focal distance of this point E. So this is the diameter. So radius R2 is equal to A minus EX1. X1 is how much here? X1 I am taking A cos theta comma B sin theta. So A cos theta upon 2 is equal to A 1 minus E cos theta upon 2. This is the radius. Directly we can write. Now, this P point is A cos theta comma B sin theta. So center C1 of this. Center is how much? This is A comma 0. S is A comma 0. So center C1 will be A cos theta plus AE upon 2 B sin theta upon 2. This is the center. So C1, C2. C1, C2 square is equal to C2 is origin. So x1 minus x2 square plus y1 minus y2 square. That means we can take A cos theta plus AE whole square plus B square sin square theta upon 4. This is also 4. This is also 4. So I am taking this as 4. So C1, C2 is how much? This is A square 1 upon 4. So this is A square E plus cos theta whole square plus B square. Now, B we can replace B square is equal to A square into 1 minus E square. So A square into 1 minus E square sin square theta. So this will be 1 upon 4 A square E square plus A square. I can take outside also this A square, that is better. I can take common this A square outside. I can put here A square. So it is E square plus cos square theta plus 2E cos theta plus sin square theta minus E square sin square theta. So this is A square upon 4 and A square 1 minus sin square theta is E square cos square theta. E square cos square theta plus this is 1 plus 2E cos theta plus 1. So this is A square upon 4 into E cos theta plus 1 whole square. So this will give C1, C2. So C1, C2 is how much from here? I will get C1, C2 is equal to. So C1, C2 is equal to A upon 2 into 1 plus E cos theta. This is C1, C2. Let us consider this as 1. Now I have to calculate R1 minus R2. So R1 minus R2 is equal to R1 larger circle is A minus R2 we have calculated A by 2 to 1 minus E cos theta. So this is A 1 minus, so this will be 2 A by 2, 2 minus 1 plus E cos theta. So this is A by 2 into 1 plus E cos theta. So we can say C1, C2 is equal to R1 minus R2. C1, C2 is equal to R1 minus R2 as these two circles touch internally each other. Thank you.